All right, so today we are going through here and looking at analyzing graphs. All right, and we're making a little booklet. Okay, now I know it's not a booklet, but this is going to be your go-to kind of go look at, refresher, help me out, let's figure this out and go type deal. Okay, so this is 5.5 analyzing graphs. We did this the other day. Some of these examples might look very similar. Okay. But they're here to help you out, all right? So what we are going to do is go through this together and talk about what each one are and look at them and try and fill them out, okay? So as we look at number one, we see that this is what kind of function? It is a linear function, all right? How we know that is it makes a line, all right? So that's nice, short, and sweet right there. All right. The big thing to notice that is different than something we looked at the other day. What are at the endpoints of these? Arrows. That means that they will continue on forever. Okay, so let's start filling out some of this and analyzing parts of the graph. The domain and the range. The thing you've got to remember about the domain is it is your x values. Well, here's what you need to notice on a linear function. When it continues on with arrows for an ever and ever, is there any x value that you can't plug in? No, you could choose any x value you want and plug it in and get out an answer, okay? Because linear equations are built that way. So that means your domain would be all real numbers because you can plug in anything you want and it'll continue on. That's what something with arrows at both ends that go on and on and on will tell you. Okay, now your range. Okay, well, as you look at this graph and you look at the y values, okay, just at the y-axis, is it ever going to stop from going up and down? No, it's not. It's going to continue on forever. So guess what that means your range is going to be? All real numbers. Okay, so as long as there's arrows at both ends, there's no holes, and it just keeps going in those directions forever, that's what your domain and range are going to be, because they will cover the entire graph. Because remember, domain is x values, range is y values. All right, now, when we look at increasing and decreasing, we want to look specifically at the graph and see where is the graph going up and where is it going down. The things that we will do to help break that up are looking at it through the lenses of the x values, okay? Well, here's what I need you to notice. What kind of slope would this graph have? It would have a positive slope because it is leaning to the right. So, what that means is you look at it from left to right, the graph is always doing what? Going up. So what you would say here, when is the graph increasing? Well, it's always increasing because we read it from left to right, and as you read from left to right, the graph is going up. So this is an example where your increase would be always because it is always going up. It never goes down. So your decrease would be never. You guys are so smart. All right, now, when you look at max or min, that's going to deal with the y-axis, and you look for either your highest point or your lowest point. Well, if you look at this graph, there's arrows on both ends. Is it ever going to get to a point where you could say, hey, that's as high as I go or as low as I go? No, it's going to keep going. So here, this would be none. Stick with me. All right, now, intercepts. This is something we've done. This is something we've seen, right? This is not too tricky. The x-intercept is where it crosses the x-axis. What would y'all say that's at? Negative 2.5. I would agree. For now, just list it. You don't have to write it as a point. Y'all with me? So just like the x-intercept is when it crosses the x-axis, the y-intercept is when it crosses the y. I would say that is 5. I would agree with you. Okay? Now, in behavior, is what it does on the left side of the graph and what it does on the right side. Now, when I say left and right side, I mean like, hey, here is the left side of my line or whatever the shape is on the graph. Here's the right side. It doesn't have to be all the way to the right and all the way to the left. It's just the ends of the graph. Well, over here on the left side, is it going up? Is it going down? What is it doing? Over here on the left side. In behavior, you literally look at the end of the graph. The arrow is pointing down. So what we say when that is the case is we say it is falling or it falls. Remember, we use the word falls or rises. Falls or rises to help us out here. Now, as we look at the right hand, it is rising. It's going up. So we would say rising. Now, if you needed to put going down or going up, I would give you credit for that. But the terms that you're going to see on a lot of my answer keys are rising or falling. Y'all okay? You sure? Yes. Any questions about any of that? Okay. I know the first time we saw it, oh, you were like, ooh, that's a lot of stuff, right? Now it's just checking it out, making sure we're good, making sure we get through all of that jazz. Okay? Y'all with me? All right. Now, let's come down here and look at our second example. Okay? Our second example is an example of an exponential function. Okay? Again, I'm not asking you to graph these, but if you were given one, I would love for you to be able to look at it and figure out what is happening. And how you do that is by applying on the right-hand side what each of those things mean. Okay? So, as we look at this, okay, what is the domain for this function? It is all real numbers. You're 100% correct. Because as you look at it, it doesn't matter where it is, you can always choose an X value. So your domain would be all real numbers. Why is it? All real numbers. Okay? Now, your range here is where it's a little bit different. Okay? And here's where you just got to kind of process and look. All right? As you look at your Y values, you've got to look at the graph. Is there anything down here where I'm moving my lightsaber right now? No. So I know for a fact that my range can't be all real numbers because the graph never gets down here. Where's the lowest the graph will get? 4. What does it do? Does everything after 4, it goes which direction? Up. So my range here has to represent something that is bigger or equal to the number 4. So when I go to list it, I would have to talk about, okay, well, my range has got to be any value where Y is equal to or greater than 4. We have to write in inequality. So what I would say here is that my Y is greater than or equal to 4. Because as I look at this, I know for a fact, which way does it go? Up. Okay? And I get that because as I look at this, it's either right on 4 or it's above 4. That dashed line cuts it in half. Are y'all okay? Oh, excuse me. Hold on. I made one mistake right here. Okay? It's not greater than or equal to. It's just greater than. Okay? It's not less than, Johnny. Here's why. I'm sorry. I made this mistake real quick. This is on me. All right? It does not actually ever touch 4. It just gets super, super close. That's something about exponentials. When you have this, it's something called an asymptote. And it means that it gets really, really close to that line, but it never actually touches. Yes, sir?
How are we supposed to tell? Because the
Exactly. So that's why I'm telling you now. Exponentials, as they flatten out, they never actually touch. They just get really, really close. Okay? So that's something now that you'll just have to recall and know. All right. Now, that was my bad. I jumped the gun on that one. All right. Let's look at this next little thing. We are going to talk about increase and decrease. Well, as we talk about increase and decrease, we got to start on the left and see what the graph is doing. Well, as I start on here and I go from left to right, what is happening? It is going up. Okay? So, let's look at that. Does the graph ever go down as I look from left to right? No. So that means it is always increasing. So as I look at this, when I talk about increasing, I would say always. If it is always increasing, that means it is never decreasing. Okay? Now, when I talk about a max or a min, I'm looking for a single point. I need a point where it stops. Does this ever stop? No, it does not, right? It never stops. So that means I would have a none when I look at my max or my min. Y'all with me? Okay. All right. Now, next part is looking at X and Y intercepts. These are easy. We've got to look and see where it crosses the X-intercept and where it crosses the Y-intercept. Okay? Well, as I look at this graph, does it ever cross the X-axis?
No.
No. Well, if it never crosses it, can I have an X-intercept? No. So when I talk about X-intercept, the answer would be none. Now, looking at the Y-intercept, does it cross the Y-axis? Yeah. At what point? 5. Perfect. Okay. All right. Now, the next part is looking at in behavior. So you got to look at the left side and you got to look at the right side. What's happening over here to the left?
It's constant, right?
Yeah, it's kind of staying constant, right? It's just flattening out. It's not falling. It's not rising. It's just kind of staying there and just staying steady. So guess what? We would say it's doing nothing. I just leave it blank. However, on the right side, which way is it going? Up. So that means it is rising. Good job there. You're light work. All right. Questions on those two? All right. Let's flip over to the back. Okay. All right. As we look at the back, this top one is an absolute value function. Okay, so we kind of got introduced yesterday when looking at graphs to absolute value, right? The special part of absolute value is it always made numbers positive. Okay, because remember, if you took the absolute value of a positive number, the answer was positive. If you take the absolute value of a negative number, the answer is negative. So they will make a V-type shape where they come to a single point and then they will grow in the same direction. So it makes a like capital V looking thing here. All right. So as we talk about it, I look on my domain. Is there any X value where I can't plug the number in? No. It goes on forever and ever and ever. Most of the time, your domain is going to be this. So what would we say our domain is? All real numbers. Okay? Here's a hint to try and help you out. I'm trying to give you this in different pieces so it doesn't feel like information overload. Unless your x starts at a point and then just goes in one direction, your domain is going to be all real numbers. Okay? That's one that should help you. That should be an easy one to get points with. All right, now, your range here. Does your range go all the way from top to bottom?
No.
No. So that tells you your range is not going to be, it's not going to be all real numbers. So you've got to look and find where is that point at? Well, as I look and I make my line, that point is where?
4.
4. Okay, now, here's the part where you've got to look at it and understand what's going on. Okay? Do we see this exactly touch 4?
No.
Yes, we do.
Yes, we do.
That comes to a point at y equals 4. Like it touches it. The other one, it just looked like it gets closer and closer and closer, and it has arrows where it continues on flat. This comes to an exact point. Since it comes to an exact point, when we talk about the range, we want to include the number 4 because that number is here. It touches. It's there. So now our range is when y is greater than or equal to 4 because we have a fact, we have a point that actually touches when y is 4. Are y'all with me?
Yes.
Do you see the difference in where the other one was kind of arrowing out? This one, you see it exactly. So your range is y is greater than or equal to 4. All right, now, increase and decrease. This is the first time that we're going to have to truly look at this. Because as we look at this graph from left to right, and we trace it, what happens? It goes down, hits a point, and then goes up. Now, when you talk about increase and decrease, you want to use that point where it changes. And you want to use it from an X look, an X idea. Are y'all with me? Okay? As you look at it, that is where X is equal to -3. Are y'all okay with how I got that? So, I just got there, all right? X is equal to -3. Now, here's how you want to break it down. What is X, or what is the graph doing from the left side till it gets to -3? It is decreasing. So that means when X is less than -3, it is decreasing. You've got to write that as an inequality. X is less than, so remember the alligator will face the other way, -3. Because for any value of X that is less than -3, it is going down. Now, on the right-hand side, what is it doing? It's going up. So that means when X is bigger than -3, it's increasing. So it's the same kind of inequality, but this time the inequality wants to face X. Are y'all okay with that? Okay? That's the easiest way to do this. Now, I will be honest. If you struggle with this, you just need to let me know. I can show you another way to do this portion and make you feel better about it. All right? I'm not going to do it right now because I don't want to overload you. But I have a different way I like to teach this, but I'm trying to stay consistent with what the other teachers teaching this course are doing. Okay? All right. Now, next thing, and this is the first time we're going to get to have this. We are looking for a maximum, a minimum, or no point. Well, what do y'all think is going to happen here? Looking at this graph, is there a point where you say, hey, that's the lowest point on the graph? Yeah. It's right here. Well, is that a maximum point or a minimum point? A minimum. You are correct. That is a minimum point, and then you've got to tell where that minimum is at. Well, what y value is the lowest we will go to? 4. So you have a minimum at 4. The next ones, to me, are the easiest ones. We look at intercepts. We have an x-intercept. Well, does it ever cross the x-axis? No. So guess what we would say? None. Does the graph ever cross the y-axis? Yeah, right here at what looks like 7. So you would say your y-intercept is 7. Now, in behaviors, it's just looking at the left end and the right end of the graph. What is the left end doing over here? Where is the arrow pointing? Up. So guess what you would say? Rises. Yep. Notice this is different than increase and decrease. It's literally, in behavior, is literally just looking at the arrows on the ends of the graph. What is the right end doing? It's also going up, so it would be another rises. Questions? Okay. All right. Let's look at this bottom one. All right. This next one is a quadratic. This is the one that you will spend a lot of time with next year. Okay. All right. As we look at it, you ready? Okay. Looking at it, do you have arrows that just go on forever and ever?
Yeah.
Is there an x value where it starts at and just goes in one direction? No. That means your domain will be all real numbers. All real numbers. All right, now let's look at our range. Is there a lowest point? Yeah. Guess what? That's going to help you set your range. It is down here at what? -4. Now, is there a point on -4?
No.
Yeah.
Oh.
Yeah. Guys, when you look at that, if it comes to like a little lull or a dull, there's a point on there. If it were like coming flat with an arrow, it would not.
I thought you meant like on the numbers.
Well, okay, yes, I meant on the line where the number is. So, yeah. So, since there is, your range needs to include -4. Now, the thing you got to ask yourself, is everything above -4 or is it below -4? It's above. So, your range would be when y is greater than or equal to -4. Just thinking about it, you just got to think range deals with y values. All right, now, increasing and decreasing, okay? Do y'all feel okay with figuring out where it's decreasing and where it's increasing? Okay? Let me just show you a little tool you can use, all right? When I like to think of this tool, I think of Little Muchacho, okay? Little Muchacho is the fastest runner of all time, all right? But he only runs on graphs. So if Little Muchacho was to start on the left-hand side, he always starts on the left-hand side. Which direction would he run on this graph? Down. That means this part is decreasing because he's running down. Now, once he gets down here to this point, what's Little Muchacho got to do? Run up, so it is increasing. Decreasing and increasing, think about if you were literally running that graph. Well, hey, I'm going downhill, 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 downhill. Uh-oh, then I got to turn and go uphill, uphill, uphill. All right? That helps some students. Now, we always want to think about this from an X perspective. Where does it cut and change directions? When X is equal to 2. You are absolutely correct. So we've got to decide. When X is less than 2, what is happening to the graph? It is going down. So to represent that, we would say, okay, well here we know that it decreases when X is less than 2. I make sure my inequality is facing 2 because I need everything smaller than 2. And then when you flip that, once we get to 2 and go up, everything is increasing. So here you would say when X is greater than 2. All right, just like before, is there a point where it is either the lowest or the highest?
No. Well, for lowest.
Yeah, for lowest. I just said a point for one or the other. You can't have both. So yes, now this point is again the lowest, which means it is a minimum. At what y value? Negative 4. That is correct. X and y intercepts. Does this cross the x-axis at any point? Yeah. How many? 2. So you get one at 0 and one at 4. Now, I showed you this the other day when we looked at this. Does this cross the y-axis? Yeah. And it's kind of tricky. It crosses the y-axis and the x-axis at the same point, which is 0. Good job, John. All right, now let's go to our in behavior. In behavior, again, you look at the arrows. What is the arrow on the left doing? Rising. What is the arrow on the right doing? You guys are so smart. Okay. Questions on any of that? All right. One last page of examples. Okay. We should definitely have time to do the first one. We might have to wait for the second one for after lunch. All right. So as I look at this first one. Okay. All right. Is there a point where X starts or stops? No. So what I'm asking you is, does it ever start at a point and just go in one direction? No. It's always going across. So that means my domain for number 5 will be all real numbers. Okay? Now, vice versa with that. On the y values, is there ever a point where the graph comes to a stop, or it turns, or it does anything like that? You might say, hey, yeah, right here in the middle, it kind of goes flat. This is another one of those. It doesn't really ever go flat. It just slowly goes and then takes a turn. So the answer here is no, because it's going to continue on where one is always going up and one is always going down. So your range here will be all real numbers. Okay. Now, increase and decrease. Remember, you got to think a little muchacho, right? He always starts on the left. Where is the left? Is it up here or is it down here? Down at the bottom. Good. So if he's down here and he's going to run, which way is he going to go? Up. And then guess what? He keeps going up and then he keeps going. Well, does he ever go down?
No.
So then that means it is always doing what? Increasing. So it always increases, which means it never decreases. Very similar to that. Is there ever a point where you have the highest value or the lowest value? No. So the max or min would be none. Whoops. Okay. X and Y intercepts. Does it ever cross the x-axis? Yes. At 2. Perfect. Okay, now, here's what I'm going to tell you. If you said no, there's no y-axis, I wouldn't count you wrong. But I want you to know what's really happening here. This graph is actually getting closer and closer and closer, and it will eventually cross. Okay? But do we know where it's at? No. So you would either need to write there's none, and I would be okay with that because you can't see one. But the better answer would be it can't be determined. So you can't tell from graph. And that's just because the graph isn't big enough. This is one of those scenarios, where I told you in the past, if you write you can't tell from the graph, I would tend to give you a bonus point. Because it's like, oh, okay, you truly understand that. We're 2BT, that's fine. I'd be down with some TBD, to be determined. Okay. That would work as well. All right, now, in behavior, the easiest parts, in my opinion, well, the second easiest parts. What's happening on the left-hand side? The arrow's going down, so it would be falling. On the right-hand side, the arrow is going up, so it is rising. All right. Let's just go ahead and stop. We've got one last example. Okay, and this is finally the first one. I'll go ahead and tell you where your domain's going to be different. All right, but we will do this right as we get back from lunch. You got a few minutes right now to relax. And ready, set, relax. Okay, we are back from lunch. All right, and now the reason we wanted to hold off on this was to make sure we had enough time to go through it and explain it. Okay, because this one, this square root function, is the first one where something's a little bit different. Okay, because as you look at it, your x's just don't keep going across, right? They've got a starting point, and then it goes in one direction. All right, this is an example of where your domain is not going to be all reals. Because if you look, it starts at this specific x value, and then it only goes in one direction. Okay, now, we know that our domain deals with our x's. Okay? At this, what is this x value where it's at? -5. Okay? Now, the other thing to notice here is it is a closed dot. Since it is a closed dot, do we include this number or do we exclude it? We include it. Remember when we did graphing inequalities? If it was closed, it's included. If it's open, it's not. All right? So when we talk about our x, we know it's going to be something with -5. Well, what are all your x's to -5? Are they bigger or are they smaller? Bigger. So your domain would be x's greater than or equal to -5. Now, similar to that, we've got a line where our y values start. What number is that at? -2. Are all your y values bigger than that, or are they smaller than that? Bigger. So for your range, y would be greater than or equal to the y value, which is the smallest, which would be -2. Okay? Now, as you look at this graph from left to right and think of little muchacho, if he was going to run this thing, what's the only direction he would go? Up the entire way. So, does this always increase? Yes, so it would be always increasing, which means it would never decrease. Okay, now, Is there a point that is the highest or the lowest?
Yeah.
Yes.
Yes. And it is this point right here, which is at negative 2. So you would have a minimum, because it is the smallest, at negative 2. All right, now, next thing we need to look at intercepts. Does this cross the x-axis? What number?
-4.
Does this cross the y-axis? Yeah, and that looks at it's like 2.5. All right. Last thing is deciding what's happening on the left end and on the right end. Well, as I look at the left end, what is it?
Falling. Yeah,
It's not falling. It's not falling.
Oh, no, it's not falling.
It's not falling.
It's
Okay.
not.
So Bennett just figured it out, and I want everybody to understand why. He just did a great job. He said, "Hey, it's falling because it's going to." Oh, wait,
It
no.
doesn't have an arrow.
There's no
It doesn't have an
arrow. There's a dot. It's not doing anything. So on the left end, there is nothing. On the right end, what is it doing?
It is rising.
It is rising. Okay?
I figured it out. He said good job.
All right. So there is that information. Now listen to me. So what you're going to do now is I'm about to pass out to you a worksheet. You're going to work on it. It's practice. What the rest of the week looks like is tomorrow I'm going to give you a similar worksheet. You've got to complete and turn in. Okay? Today is practice. If you do not do your practice, it's going to hurt you.